We are doing O-Level 2014 A-Maths Paper 2, Question 2. In this question, we are given this polynomial and we are asked to find the remainder when this polynomial is divided by x minus 2. That means if we take this polynomial divide by this x minus 2, we're going to work out the long division. The value here gives us the remainder. So we are asked to find this remainder. But getting a remainder from the long division is rather long, so we are going to use the remainder theorem. Remainder theorem says if this polynomial is divided by x minus 2, we just let the divisor, the x minus 2, to be 0. This will give us x equal to 2. And we are going to substitute the 2 into this polynomial. By doing that, the result will give us the remainder. So x substitute by 2. And this will give us negative 12. Again, this remainder here will be the same as this value here if we are going to find the remainder by using the long division method. Here we conclude our answer. In part 2 of the question, we are supposed to show that x plus 2 is a factor of fx. That means if we are going to take the fx divided by x plus 2, if x plus 2 is a factor of fx, then the remainder must be a 0. This is the same as saying 2 is a factor of 16. If we take 16 divided by 2, we know that the remainder is 0. So we can conclude that 2 is a factor of 16. So again, to find the remainder, we let the divisor to be 0. And we substitute the value of x equal to negative 2 into the polynomial. By working out the value here, it will give us a value of 0. That means if we take fx divided by x plus 2, the remainder is 0. Since the remainder is 0, we know that x plus 2 is a factor of fx. We conclude our answer here. We continue to do part 2 of this question. In this part here, we are supposed to solve fx equal to 0. Now to solve this equation, let us factorize the cubic equation first. Since we know x plus 2 is a factor of fx, we know one of the factor of this polynomial here is x plus 2. And because this is x power 1, the highest power in this polynomial is x cubed. So now we left with a quadratic expression, which is a ax squared plus bx plus c. Ax squared multiplied by x will give us the highest power, x cubed. Now we need to find the value of a, b, and c before we can factorize this quadratic expression. To find a, let's compare the coefficient of x cubed. The coefficient of x cubed, right, will be the highest power in this term here multiplied by the highest power in this term here. So the coefficient of x cubed will be just a. 1 multiplied by a will be just a. And is equal to this coefficient here. So we know that a equal to 2. After we compare the highest power, now we're going to compare the constant. To get a constant from this expression, we just take the constant multiplied by a constant in this expression. So it's 2c. And this is actually equal to 6 in this part of the expression. So we get the value of c equal to 3. After we compare the highest power and the constant, we can compare the coefficient of x squared or x. For here, I'm going to demonstrate how to compare the coefficient of x squared. To get the x squared term, for here we need to take x multiplied by another x to give us the x squared term. So this is 1 times b, so is b. Another possible x squared term can be obtained from here, 2 times ax squared, so it's 2a, so positive 2a. And the coefficient of x squared in this side of the expression is negative 3. And we know that a, take the value of 2. So we know that b will be a negative 7. Now we are ready to solve the equation. Now this expression here, we know that is equal to this expression here. So now the value of a, take the value of 2. B is negative 7 and C is actually a 3. we can factorize this quadratic expression. Therefore, x take the value of -2, half, or 3.